Welcome back to our lesson in Finite Mathematics 1, Geometric Transformations. In our previous video, we explored translations and reflections, ways we move figures without changing their shape or size. Now, let's dive into another exciting type of transformation, rotation. Rotation in mathematics is a transformation that spins or turns a figure around a fixed point, called the center of rotation. This movement happens at a specific angle, like 90 degrees, 180 degrees, or 270 degrees, and in a specific direction, either clockwise or counterclockwise. The shape doesn't change its size or form, but its position and orientation do. Let's break it down with a real-life example. Imagine the hands of a clock. Every time the minute hand moves, it rotates around the center of the clock. When it goes from 12 to 3, it turns 90 degrees clockwise. From 12 to 6, that's a 180-degree rotation. Another example. Picture a basketball player spinning around to dodge an opponent. Their body rotates around a fixed foot, just like how a figure rotates around a point in math. In Desmos or on graph paper, we can rotate shapes using rotation rules. For example, a 90 degrees counterclockwise rotation moves a point, x, y, to y, x. A 180 degrees rotation? That becomes x, y. A 270 degrees counterclockwise turn, or 90 degrees clockwise, maps x, y, to y, x. And yes, it's still the same figure. Same size, same angles, just turned. So, why is understanding rotation important? Because it shows how objects move in space. Engineers, architects, game designers, and artists use it all the time, whether it's rotating a gear, creating 3D models, or animating a spinning character. So next time you turn a steering wheel, rotate a picture on your phone, or spin a spinner in a board game, remember, you're applying rotation, one of the key concepts in geometric transformations. Stay tuned, as we'll practice identifying and performing rotations on the coordinate plane in our next segment. Key terms in rotation. To truly understand how rotation works in geometry, we need to be familiar with a few important terms. These terms help us describe rotations precisely, both in math problems and in the real world. Let's begin with the first one. 1. Center of rotation. The center of rotation is the fixed point around which a figure turns. It doesn't move, it stays still while the rest of the figure rotates around it. A great way to picture this is to imagine a spinning wheel. The axle in the center doesn't move, it's the pivot point, but the rest of the wheel turns around it. In geometry, this point can be inside the figure, like the center of a triangle, or outside of it, depending on the transformation. Think about turning a doorknob. Your hand rotates around a fixed center, that's rotation in action. Or spinning a fidget spinner, the middle stays in one place while the rest rotates quickly around it. The concept of a center is key, because every point in the shape moves in a circular path, centered on that pivot point. 2. Angle of rotation. The angle of rotation tells us how far the figure turns around the center of rotation. It's measured in degrees, just like how we measure angles in a circle. Let's break it down into common examples. A 90 degrees rotation is a quarter turn. Imagine turning a book so it's standing on its side, that's 90 degrees. A 180 degrees rotation is a half turn. Like flipping a sign to show the other side, it's facing the opposite direction now. A 270 degrees rotation is a three-quarter turn. The object turns almost all the way around but stops just before returning to its original position. And finally, a 360 degrees rotation is a full turn. The figure spins all the way around and ends up right where it started. In real life, think of a carousel or Ferris wheel. As it turns, the angle of rotation increases until it completes a full circle. So, whether it's a simple turn of a shape or a spinning top, the angle of rotation helps us describe how much rotation is happening. 3. Direction of rotation. The direction of rotation tells us which way the figure is turning around the center. There are two possible directions. Clockwise, or CW, means the figure turns to the right, just like the hands of a clock. Imagine turning a screw with a screwdriver, that's a clockwise motion. On the other hand, counterclockwise, or CCW, means turning to the left, opposite the direction of a clock's hands. Think of loosening a jar lid, it usually turns counterclockwise. In geometry, the direction matters. For example, rotating a point 90 degrees clockwise gives a different result than rotating it 90 degrees counterclockwise. So when describing a rotation, we always include both the angle and the direction, like saying, rotate 90 degrees counterclockwise, or turn 180 degrees clockwise. Understanding the direction helps us know exactly where the figure ends up after it turns.
Okay, so we will have examples on the rotation. Actually, in rotation, we have three variations of rotation. So the first one is the figure or the object is rotating on its edge. So for example, the center of rotation is point A. So that is one. Another variation of rotation is the center would be the center of the figure, or the center of the rotation is the center of the figure. Another variation is when or the center of rotation of the figure is at point 0, 0. So let's have an example. So we have this figure A, B, C. So A is 2, 1, B is equal to 4, 1, C is equal to 3, 3. Actually, what I am using is I have this formula. X prime is equal to, or the new coordinate of the point is equal to x minus h sine or cosine theta, let's say that's w, minus sine or y minus k sine w, or the angle, plus h. So this will be the formula that to get the new coordinate of the point. So this will be y prime is equal to x minus h. Instead of cos, we have sine minus y minus k cos the angle plus k. Oh, I'm sorry, this should be plus. It has to be plus. So this is the formula. Again, x minus h cos w minus y minus k sine w plus h. Then for the y prime, x minus h sine w plus y minus k cos w. Your x and y are the coordinates, or the coordinate of the point. So this will be your x and this will be your y. And for h and k, it will be the coordinate of the rotation of the figure, or the center of the rotation of the figure. Say for example, if we want to rotate the figure, so the center of the rotation of the figure will be 4, 1, then your h will be 4 and your k will be 1. So that is the formula. Pero for the sake of easier computation, may I just remove this? So, and I will change x into a and y into b. So I will have sliders here, so we can easily compute for the coordinate. So this will be a and this will be b. This is for the sake of computation, and we will have k also. So for example, let's have the center of our rotation is point A. So may I just change the color so we will have better visual. Let's make it 8 already. Yeah. Oh, that's one. Or maybe change the into star. Okay, So the star will be the center of the rotation, which is on 2, 1. So by using the formula, so we will just substitute AB again. So let's have first C. So we will change the position or the coordinate of C. So to change that, so the coordinate of our C is 3, 3. So meaning A will be, A will be 3 and B will be 3. So our H is 2 and our K is 1. Our H is 2 and our K is 1. Then the angle is again, or we will rotate the angle to 90 degrees. So let's check first if it is on degrees. So if not, then you have to change it on degrees. So B is equal to 3. Then we already have 0 and 2. So the coordinate of C1 is equal to 0 and 2. So that is our first coordinate. So as you can see, we can easily visualize if this is 90 degrees. However, let's try B. So B should be a vertical line here. So we can say that it is on 90 degrees. So we can easily imagine. So for B, the coordinate of our B is 4, 1. So A should be 4 and B should be 1. So the coordinate of our B1 sub 1 is 2, 3. So B1 is 2, 3. Oh, so that is now our the new coordinate of our B. Then let's use the polygon function of Desmos B1 and C1. So we can now create the new triangle. So we can see that the triangle rotated 90 degrees counterclockwise by using this general formula. So we can also have 180 degrees. So if we want 180 degrees, so it means that if we have B, then it will be a horizontal line here because it rotated 180 degrees. So if we try, then let's change this one. So still we will use A as the center of rotation. So we will not change the H and K, only the angle and the point. So since we have B, this one, the coordinate of our B is still 4, 1. So A is 4 and B is 1. However, we have to change the angle into 180. So we have 0 and 1. So our B2 is equal to 0 and 2. Oops, I'm sorry. 0 and 1. So we can see that it will form a horizontal line here. So because it rotated 180 degrees. Now for our C, then our C a while ago, do not use the second triangle. Use the coordinate of our pre-image or our old triangle. So for C, 3, 3. So let's change A into 3 and our B into 3. So we have the coordinate 1 and negative 1. So C2 is equal to 1 and negative 1. So that's it. That's our C2. Let's label that one C2. This is our B2. And then let's use the polygon function. Polygon A, B2, and C2. So that's our triangle. or the image. Again, by using the formula. Now, how about if you want to rotate it? So it means that if you are going to rotate it 90 degrees clockwise, then you have to subtract it to 360. So 360 minus 90, that will give you 270 degrees. So you have to set the angle into 270 degrees, because this formula only works for if the rotation is counterclockwise. Then you just have to use the coterminals of the angle. So that's how you are going to use the formula. Now let's try to have the 270 degrees rotation. Okay, so let's change the angle into 270 degrees. Then again, this one was C, so let's rotate it. Let's rotate the C first. So 3 3. Yes, so that's it already. Then we have 4 0. Our C3 is equal to 4 0. So let's label that one into C3. C3. Okay, so that is our C3 already. Then how about for our B? Our logo is 4 1, right? That's the original coordinate of our B. So let's change A into 4 and our B into 1. So the coordinate is 2 negative 1. So B3 is equal to 2 negative 1. So let's label that into B3. Then let's form the triangle by using the polygon function. Polygon A, B3, and C3. So the black triangle. So that's how you are going to use the formula. Now, how about if the center of the rotation is at 0 0? So how are we going to do that one? Oops, I deleted, no. So the center is at 0 0. So let's change this into that one. Then let's make it purple. Let's have another point, which is 0 0, or the point of origin. So let's change this into that one. Then what if we make it 10? Will it change? No. I guess this one, 10 or 20. Yeah, that one, the star. So H and K will be 0 0. So automatic that our H is 0 and our K is 0. So if you want to rotate, so let's have 90 degrees counterclockwise. Then let's change this into 90. And then this is our B, I guess, for 1. So the coordinate of our new B is negative 1 4. B1 is equal to negative 1 and 4. So let's put a label here, B1. Then our C1 is equal to 3 3. Oh, so let's change it first. 3 3. So we have negative 3 3. Negative 3 3. So let's label it to C3. So where is our point? Now how about for our A? For our A, that would be 2 1. 2 1. 2 1. So we have negative 1 and 2. A1 is equal to negative 1 and 2. So we have already the polygon or A1, B1, and C1. So that is now the rotated triangle when the center of the rotation is at 0, 0. So as you can see that our A or A1 to B is or form 90 degrees. So from a horizontal line, it formed a vertical line. So you can also solve for the distance of this to prove that um, they have congruent distances. So that's how you are going to use the formula. So again, you are going to use x prime is equal to x minus h minus y minus k. So this one, y prime is equal to x minus h sine theta or the angle plus y minus k cos theta or the angle plus k. On the other hand, x prime is equal to x minus h cos w minus y minus k sine w plus h. So that's the formula that you are going to use. It only works if the rotation of the angle is counterclockwise, but it also works for clockwise, but you have to change the angle, or you have to use the coterminal angle of that. So that's all. Goodbye.